Okay, let's start. Chapter number 7, it was about constructors and some other supporting tools of C++ programming language. We looked at constructors, definition, how to call constructors. Then we looked at inline functions, static data members, and static function members. At the end of the chapter, we looked at vectors. And I think we didn't finish up with the vectors yet. Maybe a little bit overview of vectors, and I will start a new chapter. Okay, so vectors are like arrays. They do exactly what arrays do, but they are more flexible, easy to use, very reusable classes, pieces of software. They are part of this library, STL. Okay, standard template library. Why do we call them templates? They are templates because I can use vectors, okay, as a template for an array for integers, or I can use vectors for example, bank account, class, etc. So it's a template of a vector, and you can instantiate this vector with any class that you like. That's why we call it template. And standard template library is like the standard library of C, okay, C language. There are many classes, there are many functions in it that you can use. And there is a separate chapter in our book that discusses the standard template library. Don't forget about your online attendance form. Okay, maybe I should make a 9:49. Yeah, good. Okay. So that was the vectors, and we said that using vectors is easy. Is an example. I have a vector. This is initialized, line 6. What did we say? In object-oriented programming languages, in Java, in C++, whatever, okay, we say that we always keep our objects initialized, okay? Here it is initialized. It is initialized with 0 elements. So the vector v has 0 elements in it, okay? Vector v has 0 elements in it. If you say like vector, let's say bank account BV, and parentheses, not the square bracket, but regular parentheses, 10. This is again initialized. It says that in this BV bank account vector, I have 10 bank account objects in it. They are all initialized with what? They are all initialized with 0, 0, $0 and 0 cents. Why? Because the no parameter constructor of bank account, remember, it initializes the bank account to 0, 0. Okay? So it always has to be initialized. If you declare a vector like this, there will be 10 constructors called, and those constructors will be no parameter constructors if you define it. If you don't define it, then default constructor will be called. And remember, the default constructor calls the no parameter constructor of all the data members of a class. So what happens here? I mean, do I know what kind of 100? I know that v has 100 integers in it, but what are the initial values? And then you will say, whatever the no parameter constructor of integer calls, okay, makes, and the no parameter of integer doesn't promise any initialization. It says that I am not going to initialize anything. That's a bad thing, but that's the behavior of the integer, okay? We didn't define it, and we don't want to change it. We don't want to change it because it is defined by C language, and we like to keep our backwards compatibility. But for any class that you put in here, it's no parameter constructor will be called, and you are the one who defined the no parameter constructor. Okay, we talked about that, and every time I enter an integer from the standard input, I push back. I call the function pushback on this vector, and I push back the element, and I don't care what kind of the allocation this V is doing inside it. I don't care if it is static or dynamic. I just use it. Every time I make a pushback, of course, V dot size will return one more number, okay, one larger number. Initially, it will say my size is 1, then 2, then 3, and etc. Okay, so two member functions, size and pushback, and of course this I, index I. Index I works VI like the arrays, and it will give you the index number I element of the vector. Of course. Okay, so this is a simple example, but vectors are not as simple as this. Of course, let's go to the C++ reference, for example. C++, maybe this one, C++com, yeah. Let's go there and let's look at the vectors. Okay, vector design, math. Okay, let's go to this one. So the vector has, okay, of course, it has a, these are the members. I think they are, well, most of them, maybe I will not talk much because you don't know what they are yet. Let's look at some of the member functions, okay? So these are the constructors, and the assignment operator is overloaded. You don't know what this structure is. Let's look at the constructors, actually. Okay, so as you see, 98, 11, and 14. Okay, so the one that we are using as the constructor is, I guess, this one. So we are saying that when we say vector integer 100, we are using this one. It looks like there is a default argument. You can specify it. So you may say that I am going to initialize my elements with this value. Okay, so value type, it says value type is, we didn't talk about them late, and we are, as I said earlier, there is a discussion about STL, and we are going to talk about these later. But it looks like we can specify other, we can specify values for this stuff. Okay, this is in 98. For the 11, we have this kind of move semantic stuff. So I'm not going to discuss that yet. When the time comes, we'll talk about it. Okay, so this is our constructors, and there are some examples here. Integer first. See, this is, give me 4 elements, and their values will be 100. And this one says that initialize my vector with the elements of the second. And this one says that initialize my vector with the elements of the third. Okay. Okay, good. So this is the constructor. Let's look at some other maybe interesting iterators. Again, we are going to talk about them later. We look at the size. Okay. Size just returns you the number of elements in it. That's it. Okay. So the capacity, let's look at this capacity. Return size of the allocated storage capacity. When we say vector int v, when we say it has 0 elements in it, that doesn't mean that it did not allocate any space, okay? Usually it allocates some space, but it doesn't use it yet. When you push back, it starts using that space. So capacity will return you the number of elements that you can insert to that vector without doing any reallocation, okay? Empty, just as the name implies, if the vector is empty, then it returns true. Okay, this reserve is this. Okay, increase my capacity to 100. That doesn't mean that resize put 100 elements in my vector. Say that my capacity is going to be that. Okay, and max size, return the max. I don't know the difference between the max size and the capacity. Return the max. I guess throughout the life of that vector, what was the max size? Maybe I forgot. returns the maximum size of the element of the that can hold. Potential size the container can reach due to known system or library implementation. Well, okay. Maximum size is this. Okay. How much can I grow this? Okay. Without causing any system crashes, etc. Sure, it should be equal to or less than or greater than capacity. Yeah. It's a max size is a very large number. So what did they change in C++ 11? Did they change anything? No. Okay, size, capacity, max size. See? So when I say vector int my vector, okay, 0 elements in it, I don't know the capacity. But if I keep pushing back 100 integers in it, size would come back as 100, capacity is 128, and the max size is this. Okay? So, well, it doesn't make much sense to, for me to look at all the functions one by one, okay? And especially if you consider there are extensions of this vector, okay? There are extensions of this vector with the C++ 11 and 14. So I'm not going to talk much about them. Maybe there's some interesting ones. So index operator, okay? Index operator, it works. At is same as index operator, okay? You could say at instead of index. Let me.
Can't we access elements of vectors like arrays in brackets?
Didn't we say that?
So why we need at for operates?
Yeah, ask your question louder so that everybody can hear it.
Why we need this at operator if we have this like array?
Okay. The question is, why do we need this at operator if it is going to access the element? Okay. So the difference between, does anybody know? The difference between, yes.
I think at checks the index first.
Exactly. Okay. At returns a reference to the ask element, but it checks if the index is within the sizes of within the size limits of the array. So if I have 100 elements in it, when I say index 150, you will not get any errors from the runtime system, any feedback. If you are lucky, you are going to get a crash. That way, you will know that you did something wrong. If you are not lucky, you will get some junk number. At doesn't do that. At always checks if your index is greater than or equal to 0 or less than the size of the vector. Okay, it always checks that. If it is not, then it does something. It does something that you don't know how to handle yet. It throws an exception. So it is like I have 10 elements in it. My vector size at, see this one? Line 11 looks weird, very weird, okay? You are making a function call and you are making assignment element. You are using this function call result as an L value in an assignment statement and you are assigning I to that one, okay? So it's a line 11. It works that way. It's like index operator, right? I could have said my vector index I, okay? I would have said that. And at is using the same thing. So if I use more than the size of the index, let's say, if I use 100 here, and if I like to make this assignment, you will get an exception and your program will be terminated. It will say that. You use out of index value. So it is definitely, so it throws an out of range exception. It is definitely safer to use at than index operator, but then index operator doesn't check the indexes, so it is more efficient. It is faster because it doesn't include an if statement in it.
How can we implement this kind of L value assignable?
We'll talk about it, okay, today, maybe tomorrow. When we look at the operator overloading. Okay, good. Go back. We looked at this at front and back. You already know that. Okay. Push back and pop back. You already know that. Insert elements anywhere that you like. Raise elements anywhere that you like. Okay. So you just read them one by one, and get see the examples and use them in your programs like your homework number 1 and 2 and etc. And there is a special vector. This is a vector of Booleans. This is a special vector because you can save lots of space if you keep your Booleans as bits instead of bytes. And it's a specialization. And when we talk about the templates, because there is a separate chapter about templates, we'll talk about this later. Okay, so vectors are like those. There is one, yeah, resize. Resize changes the size of a vector. Okay, so you like to make your vector larger or smaller. Maybe you can use it from time to time. Of course, this modifies it. So this is a const function. Okay, see, this is a const function size. Okay, but resize is a non-const function. Okay, good. Okay, let me go back to my, well, that was the end of the chapter actually, vector efficiency. You can reserve your, okay, if you use pushback over and over again, every time you might be doing a deallocation or allocation that's inefficient. I don't know how it does it, but if you know that there will be 32 integers anyway in your vector, but for now your size is 0, maybe at the beginning you may reserve 32 integers, okay? When you do the pushback, there won't be any allocation, okay? Because you already reserved that much space in your vector. Good? Okay, did everybody sign their names? Anybody having any problem? You did not? You could not? Okay, during the break, come here and tell your name to my mic, and I am going to record it. Let's check this attendance thing. Any questions while I am doing this stupid thing?
How can we declare two-dimensional vector size?
You didn't do that yet in your homework? We talked about it sometime in the lecture. You say vector, a two-dimensional vector is a vector of vectors, right?
I'm okay with it, but I must know the size of it. Is it two consecutive parentheses?
Oh, okay. How do you specify the size of it? Well, I mean, there are, well, we did not look at the details of the vectors yet, but remember that initialization thing. If you initialize each of your objects with a known size vector, then, right? Get a known size vector and initialize it with your with this known size vector, and that will be, what happened? I am already in. Am I already in? Yeah. This one. Okay, close and open in Excel. What I'm saying is you would do, remember the constructor that takes this initial thing. Okay, so I am initializing my vector with hundreds. If I am a vector of vectors, I am going to initialize each of those vectors by a one-dimensional vector. And you are going to define a one-dimensional vector there.
Can you use just like two adjacent parentheses?
I don't remember off the top of my head right now, but I don't remember such a thing exists. but that definitely would be a shortcut. Just read the groups, ask the Stack Overflow. I am sure many people asked it. So today is 24th. Recep, Furkan, Beyza Acar, Ahmet Yiğit, Emre Oytun, Tayyip Soner. Oh, that's it. Onur Atasever is the... Onur, how did you do that? 3 seconds? Where is Onur? How did you do that? Copy paste? Okay. I don't think that anybody... Oh, there is Abdullah. Abdullah is doing the same thing. No, what? There is 2 seconds. Afia, where are you, Afia? How did you do it in 2 seconds, and how come you are listed as fourth? Okay, these are very... Okay, congratulations.
This column is the starting time. Starting time. And completion time.
Oh, really? Oh, there is a... Okay, this is start time, and there is a completion time, and with the completion time, yeah, so...
5 seconds.
Yeah, honor is 8 seconds. So there is still, we have still some headroom for the theoretical limit of 1 second or 2 seconds. Good. Okay. So we found the solution for this, and as I said, I am doing this for you. Okay, that will be it. So in this chapter, we looked at the constructors. Constructors are just a member function, but they are special member functions. They are initialized. They are used for data initialization, validity check, and etc. And default constructor, remember, no parameter constructor, I call it. And if you don't remember my favorite class, class A, okay, there is a default constructor in it, okay? There is a default constructor in it. That's why I can say things like this, right? I can say things like this. So there is a default constructor in it. And this default constructor is defined if you don't define any constructors. And then we have class member variables, and we initialize them with our constructors. And we call const by reference, call by reference, const call by reference, etc. We talked about them, inline keyword and inline functions, and static member data members and the function members. We talked about them. Lastly, we talked about the classes. Now, if there are no questions, then I will start our new chapter, which is about operator overloading. Yeah. Operator overloading, friends and references. Yes.
What does the default constructor of an empty class initialize?
It doesn't initialize. Well, what was the task? What was the task of the default constructor? It calls the default constructor of all the data members. Okay. If we go back, and if we let's look at this, yeah. Let's see one of our earlier classes from chapter number maybe 5. Is chapter number 5, 6 maybe? Yeah, chapter number 6, yeah. So this one doesn't have any constructors. So what does it do? It calls the default constructor of this integer, r. But the default constructor of the integer doesn't do anything. It doesn't initialize anything, right? So that will be it. Instead of r, if I had day of year, okay, day of year r, then it's going to call day of year default constructor, day of year no parameter constructor. What does the day of year no parameter constructor do? It initializes this object with 1, 1, right? So that's the task of the default constructor. Call all the no parameter constructors of the data members. And most of the time it works well. Sometimes it doesn't work well. So in that case, you are going to do something else. Okay, let's go to chapter number 8, and let's open our first. Okay, now we have this money class. Instead of using our bank account class, this is very similar. This is just money to represent money. Okay, to represent money. Money is represented again by the dollars part and the cents part. It's very similar. See, it is almost same as the bank account class. We call it money. Constructor, constructor, constructor, and constructor. Okay, and getters. I guess there are no setters. Just to keep the class simple. Our nice constant function modifiers, our dollars per cents per. And remember, I didn't like these. Can anybody tell me why I didn't like these? Why these are not likable as a class function members, even though they are private? I am hiding them from outside, but I still don't like them. Do you guys remember why I don't like them? Get amount, get dollars, get cents are nice, but dollars part is bad, round is bad. They shouldn't be part of this class. I don't like them. You might say that, yeah, well, that's your psychological problem. It's not our business. And I say, yeah, well, that's true, but you have to deal with my psychological problems to get a passing grade from this class. Yes?
Are they useful though? Like you can access them.
Useful and I don't like them are different things, right? I mean, they are useful. Of course, I call them, but they shouldn't be part of this class money. Remember what does cents part do? Can anybody tell me? It takes a double, $5.25, 5.25. It returns 25, right? So that's all it does. What is the encapsulation? Can anybody tell me what the encapsulation is? Yes. That's information hiding. What is encapsulation? You put a little bit more on it. Yeah, it is. Encapsulation is a little bit more general than information hiding. It was about capsules. Yes?
These functions don't use private memory.
Yeah, these functions, when we connect it to the encapsulation, these functions, they don't use my data at all. What was the definition of encapsulation? You put your data in a capsule, and you define all the functions that work on that data, okay, that work on that data, and you capsule them. You put them in a capsule, and that's called encapsulation. How about this? How about these functions? These functions, they don't work on that data, on this dollar part or the cents part at all. They are like global functions. They don't need to be part of this class. And I am making this class crowded, even though I don't need it. I mean, it is no different. It is no different than putting a cosine function that takes a double. Okay, it takes a double and it returns the cosine of that double. That's it. It is no different than that. Okay, cosine is a useful function too, but it doesn't belong to this class like the round. Okay, round doesn't belong to this class. That's why I don't like them. Well, maybe to address this problem just a little bit, maybe I can do this. Okay, I know what I am doing. I am going to declare these three functions as static. What does that mean? It says that these functions will not work on this data. Remember static functions? they cannot work on the non-static data members, or they cannot call any non-static functions, right? So I'm kind of indicating that these functions, well, I don't like them to be a part of this class, but at least I am telling the compiler that I know that, and I promise that these functions will not make any modifications, any excesses in my private data or public data, or whatever. Or these functions will not call any of these non-static functions. Okay, so remember the principle of least privilege? I kind of obeyed it. So now I like these functions a little bit more, but still they are not part of this class. They should be something different. I like them to be globals because they might be very useful as a global function, but in object-oriented programming languages, we don't like global functions. We like functions to be part of something. You might say that, where am I going to put these? But maybe we can put them in some useful place later. Okay. Yeah.
Can we put them in another class? Maybe declare a local class?
Well, some people do that. Like I said in last lecture, I guess you were not listening. Nobody answered this. Java does that, okay? Java puts all math functions in a class named math, okay, as static functions. Remember that? So you call math, scope, resolution, sine or cosine or square root, and etc. Okay, so I made them static. Now a little bit happy, but not much happy. I'm going to find a solution to this one when we talk about the namespaces later in this semester. Okay, so let's see our main function without looking at further in my source code and etc. So your amount and my amount. Your amount is obviously 0, 0. My amount is $10.09. Okay, and I get your amount from input, and output is there. Your amount output will be printed on the screen. My amount will be screen, and I am going to do this. Your amount, is your amount equal to my amount? So what is this? This is somebody has overloaded this operator, equal to operator. Okay, now it works. Okay, somebody has overloaded it. I am comparing two money objects. If they have the same amount, okay, I am going to print we have the same amounts. Other than that, okay, I'm going to print one of us is richer. The same thing, the plus operator. Okay, it works because somebody has defined it, and we are going to see how it was defined. What else? So I added both of them, your amount and my amount. It is now our amount. I can output it, and I can print it on the screen. Do I have anything other than that? Yeah, minus sign. I am taking this much off from your amount, and it might be a negative money, but that's okay. I can do that. And interesting thing is I can do this too. That's very interesting. I am adding an integer to a money object, and it works. And I am adding it the other way, and it works. And this will work too, right? This will work too. Line 65 works too. Okay? Because this plus this plus this, okay, will return a money object, and money object has output function. I know. Compiler knows it. Okay? So let's see how we are doing this. Whenever this compiler sees this line, okay, it says that, well, there is an operator, and the compiler sees the operator this way. Are there any functions named operator? I am trying to find the equal sign. Is it here? Okay. Is there a function named operator equal to, and it will take these two parameters? Can I call this? are there such a function? You might say that this name is not a good function name, right? But that's true, because in a function name you cannot include these kind of special characters, but this is just an exception, okay? This is just an exception to define this kind of operators, okay? And I didn't show it to you, but yes, there is a global function, okay? There is a global function. Its name is operator equal to, okay? It will take two constant object references and it will return a Boolean. So the compiler says that, okay, I can make this call because there is such a function, okay? And in fact, whenever the compiler sees such an infix notation, okay, we call them infix notations, it makes this call. It just makes this call, okay? Operator equals your amount and my amount. And that's the basic rule of operator overloading. Whenever, okay, let me put it in here. Whenever a compiler sees this expression, a plus b, a minus b, a equal to b, okay, a less than b, and etc., it's going to try to call either this one, a global function, operator plus a comma b. It will try to call this function, or it will try to call a dot operator plus b. Okay, so what does that mean? A has a class. Inside this class, there must be a function named operator plus, and it takes a parameter or whatever the type of this b is. Okay, doesn't matter what this operator here is. Okay, let's say operator times, or I call them star, whatever. Okay. So if you like this operator to work on your class, on your new class, then you either define this global function or this member function. That's it. In this case, we defined this global function and this global function and this global function. Okay? Remember, look at this one. It says this plus operator will take two money objects as constant references, and it will make a new kind of money object, and it will return it.
Why it return const?
We'll talk about it later. Okay, so it will take two money objects again, and it will return another money. Let's look at the implementation of this equal to operator. Well, let's look at this one. Another constant, right? What is the difference between line 30 and line 35? Operator minus, return money. One of them takes a single parameter, the other one takes two parameters. The difference is one of them will be called when I do this. I can say money one minus money two. Makes sense, right? And assign it to money three. This will work, meaningful. How about this? Money three gets minus money one, right? Just a negation of it. This is binary, this is unary. Okay, binary and unary minus operators. Okay, so those are different. Let's go to the implementation of this. I mean, don't get confused about this. This is no different than this function, right? What did I do? I just replaced this operator equal to with equals function, name is equals now. And instead of making this call, I am going to do this equals, okay, your amount, comma, my amount. So it is exactly the same thing. So the operators are actually, we call them syntactic sugar, okay? We don't need any operators in our programming languages at all, okay? Instead of the operators, we can use our regular function calls. Instead of this is equal to operator, I can write a function named equals. It will take two parameters and it will just return true or false, okay? So why do we use operators? Well, human beings like them, okay? When we see them, we kind of read them more conveniently. So I can say things like a plus b divided by 7 and multiplied by c, okay? I can write this a plus b very easily. It's just add a b, right? But this looks like it's not going to work because there is the precedence rules. Okay, the precedence rule says that first divide b by, okay, divide b by 7 and then do what? Do the multiplication, then multiply whatever the result of it with c, and then add a comma, right? It is much easier to read this one than that one. That's why we use operators, okay? So I don't need them, but they are useful to write these kind of arithmetic expressions, and making this equals is a little bit more to write and etc., that kind of stuff. That's why we have operators. We don't need them, but we have them. So as I said, operator overloading is not any different than defining a new function like this equals. Instead of giving this name equals, I give it a name operator minus operator equal to, and when I call this function, instead of calling the function equals, I just use this simple operator like that, okay? So that's it. By the way, this one works, okay? This one really works, okay? Operator plus, you call operator plus. See, the environment, the development environment makes this one even bold, right? It's like a keyword, right? Operator plus, it's like return. Operator plus my amount and your amount, and you add more money to it, and you call the output. So lines 67 and 69 are exactly the same. They produce exactly the same assembly code. Their efficiency is exactly the same. For the compiler, there are two things that are equal to each other. But this one is more readable for us, for human beings. This is more readable, right? This is less readable. Okay, let's look at this. Let's look at this operator plus. Let's look at this operator plus. Operator plus will get two money objects as const references. So this is our algorithm. Algorithm is very simple. Did you guys get the algorithm? It will get the cents part. Okay, get cents. Then get dollars and get dollars. Okay. It is using the public interface, no problem. It is not accessing any private data members. So it is calculating the cents part from the cents and dollars part. So the total cents is this much. This is an integer. So I take the integer division total cent 100 and total cent modulo 100. That will be my new money object, and I am going to return it. That's it. That's it. Okay, so the plus operator works this way. Okay, so what is the difference between this one and this one? Well, okay, this is just a simple implementation. The book implements it in a different way. Is that true? Well, yeah, it is. Well, this one ignores the negative ones. Maybe this is not a very good implementation. Negative values, remember the negative values? If my money is a negative money, then both the cents parts and the dollars part should be negative. And I have problems with the modulo operator with the negative values. So the implementation is this. All cents 1 and all cents 2. I get the cents of, I don't use the dollars, I only use the cents. So dollars times 100 plus the cents for the money 1. This is money 2. And I add them up, all cents. And this is all cents part. Then these are the absolute cents, the final dollars. These are the final cents. And if sum all cents is less than 0, then I make them negative. So I do all of my arithmetic in positive numbers. And if my final value is negative, then I make them negative and I return it. Money can be negative. This doesn't handle it very well because if you take the modulo of a negative number, this is not what you expect. Okay? I think this is the better implementation from the book. I am going to do exactly the same thing with the minus operator, but looks like, okay, let's look at this minus operator. Okay? This minus operator, it does exactly the same thing. I guess the only difference is this part. Line 28 is negative, okay, integer subtraction. Line 103 is, okay, it is plus and minus signs, that's it. So it kind of lots of code copy and paste. Okay, so let's look at this unary minus operator. The unary minus operator is just simply this. It is very simple to define. It takes a money object and just returns another money object. It is exactly the same as this money object, only the dollars part and the cents part are negated. If they are negative, they will be positive. If they are positive, they will be negative. Just wake him up. Yeah. Oh, yeah, that too. Okay. Yes.
Can I define my operator with a random symbol or any?
Well, this is called operator overloading. It is not called operator creation. Operator overloading means that it has a meaning, but I am giving an additional meaning right now, okay? You cannot create new operators, okay? That operator has to be part of C language. If it is not, then no, you cannot make up new operators. That's the rule. Okay, that's a good question. Any other questions? Yes.
I have a question about static function members. I can add integer a and integer b in a static member function, but a static member function can only call static function.
Yeah.
But it works still, does it not?
Well, in our case, I mean, are you asking a general question or your question is about this?
It's about the last lecture actually. We can add two integers even though add operator isn't a static as far as I know.
Well, the rule is you cannot call static function members of the same class, or you cannot access, you cannot call non-static function members, or you cannot access the non-static data members of the same class, okay? So if there are other class and you are going to do stuff, then you are free to do it. Even in the, I mean, this dollars part, even though it's a static, it cannot access this input and output. Why? Because there is no object in it, right? But I may define a temporary money object in my dollars part function, and I call its input and output, no problem. Okay, so you cannot call it on my object because this dollar part doesn't have any my object thing. Yes. In terms of what? Well, that's what I said, right, previously. These are exactly the same things, and instead of, they will produce almost the same assembly code. Instead of produce function efficiency, they are exactly the same. They are just two different names for the same function, you may say. Okay. So what did I say? We call this as syntactic sugar. Okay. We don't need them, the operator overloading. We don't need the operators. We can handle everything with functions, but we use them for our readability. Without the operators, I can write my code, and they will be equally fast. Okay, so there is no difference between them in terms of efficiency, memory efficiency or CPU efficiency. Yes, any other questions? Okay, so that's basically it. So you might say that, well, we don't like global functions. How come we are writing global function right now? Yeah, I might say you are true. We shouldn't do that. Okay, we shouldn't write global functions. Oh, by the way, how did this work? Okay, line 64. This operator, this means what? There must be a function that will take one money object and one integer object, right? There must be a function like that, and in fact, I think I defined it. Yeah, here it is. See? One money object and one integer object. So you can do that too. So you are defining a simple function. The name happens to be operator plus, but it's a function. And this is overloaded again. I am giving a additional name meaning to operator plus, and that will be it. Okay, so that one will work too. We are going to come back to this topic later. Okay, so let's go back and let's again. We don't like these global operators. Let's make them our member functions. Remember what I said? I said that when the compiler sees such a thing, okay, operator star, okay, it either calls this one or this one, okay, whichever is available, it calls that one. So instead of implementing this function, global function, we are going to implement this function. Okay, let's do that, and let me open our second part of this thing. Yeah, let me show you this. And see, I made this line 19, 20, 21, 22. Now they are now my member functions. Okay, and we are going to look at them. They are a little bit they look a little bit different. Why? Because they have a single parameter. But we will talk about them in a few minutes. But before, I need to take some break. Okay, now it is 26. Let's be here around 36. Don't be late. We will continue after that. Sen miydin?
Hocam ben de yoklamayı imzalayayım.
Adın ne?
Ahmet Hakan Sevinç.
Furkan Baran.
Eğer dersten yoklamadan kalırsanız gelin hocam, kaydınız var burada dersiniz. İnanmaksız ama olsun. Günü de hatırlayın. Niye doğru? Ne yazıyor ki burada? Ha, ödevle alakalı bir şey. Ne ki?
Ödevdeki örnek de normal. Ödevdeki örnekte şu K'yi böyle çevirmiş, K'yi de böyle.
İki boşluk var değil mi bunda? Üç boşluk var mı? İki boşluk mu var? Bir, iki, üç boşluk var.
Böyle de sayalım mı?
Tabii ki. Buraya da bir şey koyabilirsin değil mi? Arkadaşlar o fil işinin sonu yok. O çözülmesi
ondan dedim yani.
zor bir problem. Esasında
Biraz ucu açık gibi hocam.
tamam, evet, ben zaten tam mükemmel bulacaksınız demedim ki.
Tamam.
Özellikle yeni ödevde tamamen.
Hocam ben yoklamaya katılamadım da sorun yaşadım.
Niye katılamadın?
Abi internetimle ilgili.
Ama sorduğum bir şey söylemedin.
Hocam o anda
Tamam uyuyun. Uyumadı ya. Evet.
Yoklamada sıkıntılar çıkıyor.
Ne gibi mesela?
Derslere katılmakta zorluk çekiyorum. Derslere katılmakta zorluk çektim ilk hafta. O yüzden yoklamadan kalır mı?
Biraz yok, biraz zor kalırsın da yoklamada. Yoklamadan kalmana gerek kalmaz ama dersen kalırsın. Anladın mı? Raporları yoklamadan kalırsanız yeter.
size bunu ekleyeceğim.
Blokların üstüne var mı? Hocaların resimleri. Şey dümdüz duruyorsa onu C'yse şöyle. Sayı nasıl yaparsın?
Sağa dönüyorum, sağa dönüyorum.
İki hocayı.
Dur basit gerçeksin.
Kare zaten kolay. Evet hocam iyi. İnsan nelere bakıyorsun kardeşim bana?
Fiyatlı remix yapıyorum.
Kaç? 19 tabii 10.
İnflasyon.
Programı yazsam. Piyano.
Hadi abi. Telefon. Tamam ödemediğim şuna bakacağım. Nereye baktın mı ödemediğim? Ha? Hiç mi bakmadın? Hile de mi baktın? Vay be, evet sen çok doğru. Ben çok doğru. Hocam ben hemen çalmalıyım. Yapamadım. Niye?
Piyango çıktı.
Piyano mu çıktı? Burada ne işin var ama?
Yazın alacağım.
Evet sen anlarsın şunu. Bir oku bakayım. Bu ikinci PDF açınca indiriyor mu?
Benimki indirmiyor. Seninki indirir. Ben de yer azdı ya. Bazen indiriyor da bazen indirmiyor.
Ödev ne? Yapma.
Yap
Ne
dostum. Korumayı kim taktı lan? Böyle.
Niye? Kötü mü?
Yok takılmış.
Hangisi?
Canım sıkıldı. Yok takılmamış pardon. Kalın olunca. Kaymış. Bak yandan bak.
Ödevler. Fotoğraf çok ödevi.
Onu yapar.
Ne yapacağız onunla? Bir tane söyleme misin?
Bir tane sorularım var.
O.
Tamam.
Ya da
Bir
şey
soru.
değil.
Bir soru diyorum. Bir soru. Nasıl ya? Yalan tanıdığın yok mu oğlum?
Şunu açıkla.
Haftada alıyorum. Sorsam haftada.
Şunu koy. Şurada ne demek çalışıyorsun?
Hani yeğenim bakayım göster bana. Ben bilirim her şeyi.
Can fit fonksiyonu diyor. Bana açıkla. Nasıl?
Öyle mi?
Basic demiyorum. Can fit fonksiyonu diyor. Onun yanında niye S'ye gelebilir? Okey. Tamam anladım.
Bunu ver kanka.
Yok anladım.
Anlamamış.
Tamam verin.
Anlamamış.
Önder. Allah Allah. Sağ ol. Dur oğlum veriyorum ben sana ya.
Veriyor mu?
Veriyorum.
Anlat. Soluna gelemiyor, sağına gelemiyor. Senin de soluna gidiyor, sağına gidiyor. Öyle mi? İki tane mi olacak aslında? Seninle nasıl ya?
Çok çiziyorum ya.
Siyah.
Bak şimdi şöyle. Ben şunu göstereyim. Şimdi
Üstüne boyamıyor mu? Önce bunu boyarsın. Şöyle boyarsın sonra. Öyle mi? Böyle bir şey. Sen bilirsin.
Şimdi şu olabiliyor. Şu olabiliyor. Çünkü şurası dolu. Ama şu olmuyor.
Yani o zaman buradan tanımlayacağız. S'nin sağına gelemez diye.
J nasıl ya?
Z işte yılan. Sağ üstüne bir parantez koyacağım.
Şurada boşluk olduğu için.
Sol olacak.
Ha, algoritma bu yani.
Fonksiyon ne alıyor? Sonuç pardon. Sonuç. Yok tamam. Blokları alıyor. Alma sırasında soldan sağa yerleştirirsin. Tamam mı? Alma sırasında döndürmeleri yaparsın. Ama en az
Kardeşim
ama soldan sağa en iyi olmayabilir bak. S koyar, kare koyar, sonra ters Z koyar. Yerlerini değiştirir.
4 oldu.
Yerlerini değiştirir. Kankalar o zaman. Yerlerini değiştireceğim ve orientation. Sırayla her zaman bol koyar. Ters Z koyar.
Nasıl böyle?
Bak orada o durum da öyle. İkisini belirtmesi koyabilir. Bol koyar, ters Z koyar. Yükseğe göre bir yerleştiremezsin ki.
Çarptım aynen.
Evet.
Hiçbir şey yok.
Oğlum bir mantığını dinlemiyor. Orada yazılır. O varsa, ters Z varsa birleştireceğiz. Karesi oldu.
Buraya geldiklerinde mi?
Ha.
Ben hiçbir şey almadım buraya geldiklerinde ya. Sen aldın sen. Aynen.
Oyla Z'yi
Yeşil.
bir şey alır. Onu git.
Hayır prensler kadar.
Sonunda saymaya sen şey yaptın
Aynen.
yani baktığında gidebilir.
Abi işte ilerideki şeyleri düşünmediğim için belki sıkıntı çıkar.
Ya tabii senin zaten doğrusu benim. Doğrusu benim işte. Öyle oldu. Değil mi? Çünkü tüm trenler falan muhakkak senin.
Hayırlı vakit. Madem geldin.
Çünkü şey biraz sağdaki böyle bakın destek daha fazla. Anladın mı? Orası öyle oldu. Yer değiştirmiş o öyle.
Ama şey,
En gerek faktörleri var.
bildin mesela ama sen
Kapıya böyle 20 bin falan.
sen oraya girdin ya atıyorum. Senin gerekli 2.80'e 100 bin adama 3.70'e eşit falan.
Burada da şimdi döndürüyoruz, en iyisini buluyoruz ya. Tüm ihtimalleri deniyoruz. Ben gittim bunu recursive aldım end'e kadar. End'e kadar gittim. Ondan sonra saydım boşları, en iyisini çektim. Sürekli hani bunu yapıyorum. Yani end'e kadar git, bütün listeyi çevre 400'leri en ihtimali al. Ondan sonra oradan en iyisini al gibi yapıyorum. Şimdi bu şekilde olunca mesela 10 tetraminodan sonra sürüyor 5 dakika mesela. Yani sıkıntı mıdır bu?
Tabii ki. Yapma öyle. Yanlış ya, olmaz, oyun oynanan bir oyun değil. Birazcık fedakarlık yapacaksın. Best fit almayacaksın. Bir şeyler bul, yap.
Anladım.
Bir
O
numara
zaman o
çek.
şekilde değerlendireyim. Sadece yanına uydurayım o zaman.
O zaman da iyi olmaz.
Yani, orası da öyle oluyor işte.
Bul yolunu ya.
Bu sayısal az önce baktık ya. Yeti 128 olduğundan bahsediyorum kabaca. Yani mesela 64'ten sonra bir eklediğinde oradan size 2 tane çıkarıyor.
Genelde öyle yapıyor ama algoritmanın ne olduğunu söylemez herhalde. Bir dokümantasyonuna bak. Pushback kompleksitesine. Genelde 2 katına çıkarlar. Yani elinde 1000 varsa birinci eklerken 1001 yapmaz. 2000 yapar. 2000 varsa 4000 yapar. Genelde öyledir. Derse başlıyorum ya. Okay, let's start. Let's start. Okay, people. Ya ne yapıyorsun? Dinlemiyor musun beni ya? Şunu oturtsana bir. Böyle mi yapmam gerekiyor? Tamam, böyle yapacağım bundan sonra. Okay, people, let's start. Okay, you have a question.
How can we add multiple class money objects even though we had cons in front of them? So
Well, they don't.
I'm not asking.
What?
I'm not asking.
Okay, you solved it. Good. Okay, the question was, how can I ask multiple tetris, whatever, Tetris pieces If they are different classes, you overload them, or you don't have, it doesn't have to be a different class, right? It doesn't have to be a different class. Same class, just parameterized differently. Another question? Well, I mean, if you, the best fit function, homework number 1 or homework number 2, I mean, at this level, I don't think that you are going to find the best function. It takes lots of time to find it, because, I mean, if you implement it in a straightforward way, it is exponential. There are ways of implementing it in a very efficient manner, but I mean, this course is not about algorithms or artificial intelligence, so I'm not going to force you to find the best fit. Okay, it is your best fit. Okay, it is not the optimal best fit. Okay, this is my best fit. It works this way. Of course, you shouldn't be as stupid as random moments. You should try to do something. Maybe at the end of this homework submission duration, we can set up a small competition about, given the same pieces, who is going to do the best Tetris playing and etc. Maybe we can do that, but I mean, try to do as good as possible, but your best fit doesn't mean that optimally you cannot do, anybody else cannot do better than that, okay?
Can I ask about
Sure.
in PDF, it say a can fit function should take an
You are talking about homework number 1?
yes.
Yeah.
Can fit function should take another tetromino object and relative position of that object.
Yeah.
And you say relative position of that object.
To the right, to the left, to the up, or to the down, okay?
Not XY position.
No, we never talk about XY position. But it says in the PDF too, left, right, and I think I gave an example too. The homework is on purpose written in an ambiguous way. It is not ambiguous, but I didn't define everything, because I like you to think about the problem and define it a little bit yourself too. And the other reason is, if two people interpret the same problem as the same, well, that's a good indication for cheating and that kind of stuff. So, I mean, normally I wouldn't expect two different people coming up with the same set of lines for a problem that I did not define all the steps of it very clearly. Okay, so you have to add your definitions into the problem and also list these definitions, that your assumptions in your homework submission too. I assume that this is this and this, such and such and etc. Okay. Good. Any other questions? Okay, let's go to the let's go to the code again. Okay. Again, these are our constructors. 1, 2, 3, 4 constructors, getters, and 1, 2, 3, 4 operator overloads. Okay, let's ignore these for now. Okay. Let's look at this operator plus. Our main will not change at all. It is the same thing. It's going to be okay, your amount plus my amount. That's it. Okay, or your amount minus my amount. It will work exactly the same thing, but our code is a little bit different now. See, this one is operator plus, but it is a member function of money class operator plus. Okay, it takes another money object and it says that I promise I am not going to modify the other money object. Maybe it should have been a not second operand, but money, other money. Okay, and I'm not going to modify. See, this one is get my cents, get dollars. Get the second one, the second operand, get cents and get dollars, and sum them up and do that thing and return a new object. Remember what we did in our previous case? Let's look at the previous case. Our plus operator here, amount 1, amount 2, amount 1 dot get cents. This one says, right, okay, I am trying to align it so that we can see it side by side. Okay, so it is amount one dot get cents. This one says just get cents. Okay. This one says, okay, amount two dot get cents. This one says really second operand get cents. So get cents is, remember how I call this? A dot operator plus parentheses second operand. Okay. So that's the only difference. It looks like I am taking a single parameter. In fact, I have two things to deal with. One is myself as object. The other one is the operand that I am taking. Okay. So, any questions on this?
We didn't define input name in public in definition of class.
Input name. What is input name?
Second operand inside public section.
Yeah, I don't have to, right? This comes from C.
Okay.
In C, when you are defining a C function header, you don't have to your online attendance forms. Everybody. In C, you don't have to give the parameter names when you are defining a function header. Okay, you are saying that I am going to get this one. In this case, I am just giving cents and dollars and etc. But I didn't have to. Okay, I didn't have to. Usually, I give the name here. Okay, O1 other ya da or other. Okay. So when I put a comment here, I talk about this. Adds this object with the other. Okay. So giving names at this phase of function definition is useful if you are going to refer to them in your commands. Okay. So the way I implement them is very simple. I just implement them this way. Plus operator. Again, this is very similar to this definition. This is a name operator plus. My new name is now money operator plus. It's not a global function anymore. Okay. And it returns a const money, this one. And the second one returns a const money too. The first one takes two parameters. Well, this one now takes one parameter because the first parameter is myself, my object. And this const says that I am not going to modify myself. Okay. This one says I am not going to modify the first parameter or the second parameter. By the way, this one doesn't access the, remember I have two private data, dollars parts and the cent part. I don't directly access them, even though I can directly access them. I am not going to do it. Okay. Instead of saying get cents, okay, instead of saying get cents, I can say cents part, right? And dollars part. Okay, but I don't like this. Why? Because I am trying to enforce this principle of least privilege. Okay, I am not going to access my private data directly. I am going to use the public interface. Even though I can, okay, I am not going to do that. And I can do the same thing with the second parameter too, because it's a money object. I am a function member. I can access these private data members, but I am not going to do that. Okay, good. Question? Yes.
How can I define integer plus my money plus
as opposed to my money plus integer thing you're saying? Is that true?
Integer plus, I don't know.
Well, I mean, if this is what you want to do, let's go to the main. I think there is an example on that one, right? I mean, yeah. How can you do that, right?
Yes.
This is doing this is easy. Why? Because let's do that. I mean, I am going to overload this plus operator so that M3 plus 1 works, okay? It is easy to do that. How can I do that? You are going to take this one and you will say just, I am going to take an integer.
Is it difference between integer plus class and class?
Well, I mean, this one, what does it do? This one, line 20 will handle this line fine, right? No problem, because
51.
object plus integer will be handled by this one,
51.
But integer plus object is going to be tricky because remember what we said? Let's go to this one. Let's go to this one. That's a good question. Yeah, well, that's a good question. Money M1 plus 1 means that M1 dot operator plus parentheses 1. So I overloaded this already. Operator plus taking an integer, right? I overloaded it. It is this one. It works. But how about this one? Plus 1 plus M1 is going to be 1 dot operator plus M1. So it looks like in the class of integers, class int, there is a member function named operator plus, okay? There is a member function named operator plus, and it takes a money object. Can I overload it this way? I mean, then I need to go to the definition of the integer class and make a modification in the integer class, right? Do I have the source code for the integer class? No. Okay, I don't. Even if I have the source code for the integer class, I cannot modify it. The integer is something standard, right? So how am I going to overload this one? How am I going to overload this one? I guess the only way to overload is what? What? Global function, yeah. Unfortunately, it's going to be the global function. Overload the global function. Operator plus as the first parameter is going to take a integer first and a money next. Okay, integer first and money next, and that will be done. So for these kind of reasons, unfortunately, we will have to use the global functions for the sake of operator overloading. Okay.
By the way, how we call this operator overload as a member function, like dot oper plus or dot operator?
Operator plus, yeah. Okay. Could you stop looking at that phone? What are you doing? Do you know this stuff? Can you explain this, how we can handle this problem? Do you know this? Why don't you listen to me now? I mean, if you know it, you don't have to come to class. Okay. So unfortunately, we won't be able to handle this kind of stuff with the member function overloads. Maybe we can handle this, but we won't be able to do that for the member function overloads. The other thing is that it is getting messy. Right? I mean, I don't have to do, okay? This is very easy. Money and convenient. Money one plus $10. This is nice, right? So I overload this one and it works. How about this one? Money one plus $20.25. Now, am I going to overload it for the integer, the doubles too? Okay, where is this going to end? That's kind of becomes a problem. The thing is that in order to make this possible, I don't have to overload this one. Just erase it. I am going to erase it. Okay. I am going to erase this one. And this still works. M1 plus 10. Why? This is how it works. The compiler says that whenever it sees this one, okay, is there any operator that I can call with M1 dot operator plus integer? No, I didn't define it. So what do I have? I have M1 dot operator plus another money object. So can I make a money object out of an integer? And the answer is yes. Answer is this. This constructor says that if you give me an integer, I can make a money object out of it. Okay? This is called a conversion constructor. Okay? This one says that if you give me an integer, I will make a money object out of it. And the compiler says that then in that case, I can make a money object out of this integer. So let me call the constructor. Constructor will be called. It will make a temporary money object whose value is $10 and 0 cents. And then it will call this plus operator that will take 2 parameters like this one. Okay. So it works automatically. So it is called, okay, implicit type conversion. Implicit type conversion. Let me write it here. Implicit type conversion. Implicitly type is converted from one type to another one. For that we use these conversion constructors. I mean, suddenly I started calling my constructors conversion constructors. Well, these are regular constructors, but your regular constructors sometimes can be used in converting from an integer to money or from double to money. So conversion constructors are the constructor that take a single parameter, just a single parameter, and I use it as conversion constructor. If I had, I don't know what the meaning of this one would be. If I had a constructor that takes a string object, I don't know how it works. Then in that case, money1 plus string ABC would work too, because there is a conversion constructor from string to money. Okay? But I don't have it, so I'm going to erase it now. Okay? So the conversion constructors are the constructors that takes a single parameter, and the compiler, I have to take this. Efendim hocam? Aleykümselam. Dersteyim hocam, buyurun. Yok hocam, şey yapalım vallahi. Arayayım mı ben çıkar çıkmaz? Konuşalım hocam, olur, tamam. Hı-hı. Tamam, görüşürüz. Okay. So conversion constructors are like that, and see, this is not a conversion constructor because it takes 2 parameters. This is not a conversion constructor. It cannot be used. It doesn't take any parameter. But these are 2 nice conversion constructors. Okay.
The other way is more syntactically sugarly.
What do you mean other way?
Global cons, global function, operator overloading functions is.
Well, it is the same thing again. I mean, for the global functions like this one, again, compiler, when it sees this one, it will try to do either this one or that one. If any of them is available, it will call it directly. If it is not, then it will try to make a new object either from this one or that one. Okay?
Is there any reason?
So just listen to me, okay? Either this one or that one. In this case, it's going to make a new object from this one only, okay? This one only. So with this case, m1 plus 1, okay, it will work with the conversion constructor. I don't have to overload with the integers. But here in this case, okay, it will not try to make a new money object out of 1, because in the class of integers, there is no conversion constructor from money to integers, okay? So this will not work with the with this notation. It has to be this notation, that is the global function overload. So if you have a global function overload, like I showed you before, like this one, okay, plus operators, this will work with both 1 plus m1 and m1 plus 1, okay? Or it will work both 1.10 plus m1 and m1 plus 1.10, okay? So again, the plus operator with the global overload makes our job a little bit easier, and in this case, unfortunately, okay, in this case, unfortunately, we will have to settle with the plus operator being overloaded as a global function, okay? We don't like it, but we have to do it for the sake of, well, I mean, you make everything your function members and overload for all the cases. You might solve some of the problems, but it will be messy. Instead, we kind of sacrifice a few principles from object-oriented programming principles, right? And we overload it this way. What did I say? We don't need the operator overloading. We don't need the operators, right? We can write everything as functions, and Java does it that way. In Java, there is no operator overloading, okay? Whatever, if you need an add function, write an add function. You don't need the plus operators. So they kept their language a lot simpler than C++, okay? But in C++, they made this available. And most of the people, they don't use operator overloading much. So why am I talking about this? Because it makes it possible for me to talk about this kind of stuff, conversion constructors, and the meaning of the difference between a global function and a local function, the meaning of object, and etc. There was a question? You had a question? Yes.
How compilers understand one's an integer instead of character? If I write a constructor that is
Well, compiler knows that this is an integer, right? Compiler knows the types.
but it's a character two. One is character.
One is not a character, it's an integer. I mean, if I say m1 plus ABC, then compiler knows that ABC is a string. Is there an operator that takes a money object and a string object? No. Can I make a money object out of this ABC? No. So this is not compilable constructor, compiler says. But if it is you are saying that if it is like a character like this, so you are saying that, can I make a money object out of a character? Okay. No. Maybe I can convert this character to an integer, then from integer to a money. Well, I can do that, but the rule is not. No. The rule is you only convert one type to another, only once. You don't do first from this to this, then from this to that, then from this to that. You only try it once, okay? Convert an integer to money, and my operator plus works for money, okay? So your intuitive logic says that, why don't I convert this character to an integer, and there is a conversion constructor for the integer? No, it doesn't work that way. There is a rule that's written in the standard C++.
One plus temporary plus in memory.
I don't understand your question. I mean, when the compiler compiles it, okay, this is a literal constant, right? I know how to write literal constant. It's an integer. I know that. And the M1 type is already defined somewhere. I defined M1 as a money object. So Compiler knows it. Okay? There is no such C program. There is no such C program that contains only A times B, right? You have to define A and B somewhere. It has to be declared. It's not like Python, right? Okay. Are you guys reading the Google C++ coding style document? It has lots of, I mean, it is not about style, it is about why we do that and why we don't do that. Okay, so you read it. It is a very useful document. And try to read the other companies' style documents. So I mean, those style documents kind of tell you what is important and what is not that important. If somebody say that this is really important, we make this distinction, you understand that it is something important. Okay. By the way, let's get rid of these. There might be some cases where you don't want your constructor to be used as a conversion constructor. Okay, it might be like that. Let's say you are writing the class vector. Let's say, okay, class vector. Let's say this is just a vector of integers. Okay, and in my public section, I have a constructor that takes an integer, right? What is this integer? This integer represents how many elements do you want from me, right? So I don't care about the rest. Do you want this constructor to be used as a conversion constructor? Okay, let's do this. Vector A, B. I can do this, right? A assignment B. No problem. Two vectors, no problem. How about this one? Do you want this to work? What does that mean? Let me make these. B size 10. I do the assignment. How about this one? Do you think that this should work or should not work? If you compile it this way, this is going to work. Why? The compiler will say that I can assign a B to an A because their types are exactly the same. Do the assignment. How about this one? I cannot assign a 2 to an A because this is an integer, this is a vector, right? I cannot do the assignment. But I'm getting as smart as the compiler. Can I make a vector out of this 2 and assign that vector? The answer is yes. If you give me an integer, I will make a vector out of it, right? So this will make a vector of size 2, a temporary vector of size 2, and it will do this assignment. This is very different than that I have intended. This is very confusing. Okay, this should not work, right? This should not work. So how am I going to prevent it? You put this C++ keyword. I am going to write it in bold letters, maybe explicit. The keyword explicit says that don't use this constructor as a implicit conversion constructor, okay? I am going to use this explicitly for constructor, single parameter constructors. For these kind of cases, don't call it, okay? This is explicitly for constructors, single parameter constructors. You are not going to use it for implicit conversion. It's called explicit, okay? Explicit is a C++ keyword, okay? If you put explicit at the beginning of this explicit, say it is bold, at the beginning of this dollars. Now from now on, from now on this will not work, because I told the compiler that don't make an object out of this $80.20 by using the conversion constructor. This one cannot be used as a conversion constructor anymore. Okay, if you put an explicit on it. Good. What? You didn't get what? Which part? If you want this to happen, okay, M3 plus $80.20 plus operator to work, this is fine. There are no operators that will take a money and double, right? Do you see it? It doesn't. There are no plus operators that will take a money and double. I have only an operator that will take money and money. But the compiler is smart to say that using this conversion constructor, I can make a money out of this $80.20 double value, right? So this is the part that we already know, right? Okay. But if I don't want this to happen, you put explicit in front of it. Why didn't I? Okay. Explicit in front of it. So this kind of automatic type conversion from double to a money will be prevented. Okay, if you don't want it. So you might say, what is wrong with this? I mean, this looks nice. Why do I prevent this? Well, in this case, you don't prevent it. This looks nice. But the example that I give you is this. If I have such a class that will take an integer, the meaning of integer is not a vector. Okay, the meaning is size of the integer. In this case, if I don't want this to be a valid expression, that means that make a new vector out of the integer 2 using this conversion constructor. Then you put an explicit in front of it, so this will not compile anymore. Okay, so basically, if you don't want your single parameter constructor to function like a conversion constructor, you put an explicit in front of it. Okay, I don't know if your book has any discussion about this in this chapter. Maybe it has, I don't know. Read about it somewhere on the net or some. Just go to. By the way, C++ 11 defined lots of, where is my C++ thing? Go to, explicit keyword, and they have changed it. This, I mean, in C++ 98, it used to be like, it used to be like only a single parameter constructors. With the C++ 11, you can do the multiple parameter constructors with the explicit. Copy constructor, I don't know which one to, typecasting maybe? Yeah. Implicit conversion, yes, here it is. Okay. Constructor that converts from another type, and this will work. But if I put an explicit in front of it, it will not work anymore. Okay. So read about this yourself. As I said, I don't have time for this in this course. This course is not about knowing all the details of C++ programming. This is about object-oriented programming. I have to keep the balance. Okay. If I only talk about object-oriented programming, this class would have been even more boring for those of you guys. Okay. You are lucky. This is not that boring. But if I keep this about C++ programming, then C++ is a very large programming language. It is very, very large. So I cannot talk about them, and I don't have to, because most of them are easy to learn by yourself. You just go read the documentation. Reading this kind of documentation is very easy. You just go to the tutorials. Well, it talks about, for example, C++ learning tutorial, okay? And it talks about constants, etc. What is to know about the constant? Constant is a constant, but no. If you go to the constants, okay, there are lots of different constant types and constant notations and etc. Remember we talked about those. And you see suddenly these character types. What are the character types? Characters are characters, right? Like single byte things? No, it is not, because as you know, we don't have the Turkish letters, yumuşak, g, etc. in our ASCII set. We need a larger character. So for those, we have 16-bit characters, 32-bit characters, and byte characters. And when you start reading about them, other things comes back. And as I said, there is no end to it practically. So you keep learning and learning and learning. So where do I stop? Well, you have to stop somewhere. The thing is that you always try to learn something and use it somewhere, and you keep doing this in your free time, in your time to develop yourself, and you will see that you will find them very useful, to be very useful in your job interviews, in your professional life.
Is C++ most detailed language? Can you say that?
I since I don't know all the languages, I wouldn't say that, but yeah, well, definitely. I mean, it is one of the oldest ones, with one of the most widely used ones. I think it is the #1 most popular language used by the real professionals. Python is used more, but I mean, it is used more because newcomers to the programming world, or the world that are not in the world of non-professional, they use it, and they have the numbers, right? There are lots of people like that, but real professionals, they mostly use Java and C++, mostly C++. Okay, everything is written in C++. Actually, I mean, all the languages, all the operating systems, all the critical stuff, either C or C++. Okay, so operator overloading, we already talked about those. Overloading basics, yeah. 2 parameters, who takes constants. I think we talked about those. Operator plus, not member function, and this is the not member function overload of it using the public interface. Nice. It has to use the public interface because it's a global function, right? Okay, we talked about this. And the is equal operator. Is equal operator, what does it do? It just compares the cents parts and the dollars part one by one. If they are both equal, then I am done. Yeah. Get dollars and get dollars, get cents and get cents. This is the equal to operator. Then it is very easy to implement the not equal to operator. You just do this. Boolean, return Boolean. Okay. Operator not equal to, and it will take a const money object A1 and const money object A2. And I will just say return just the opposite of what the equal to returns. Okay, so what am I going to do? I will say A1 equals A2. If they are equal to each other, okay, then return false. If they are not equal to each other, then return. Okay, that's it. So this one is calling this one. And it would make sense to inline it, right? It's a very simple one line of code, and inline this too. Okay, so we already look at those. Okay, constructors, I'm going to skip this one. We already looked at those. Yeah, okay. So there was a question about why are we returning a constant money? We are returning constant money because this is good, right? M1 plus M2 dot output. It is both legal and it is intuitive. Yeah, I can do that. But how about this? M1 plus M2 dot input. I mean, this will compile and run, but it is problematic. Why? Because M1 and M2 returns a temporary object. It will go away. It will be dead. But I am running this input on it. I am getting some numbers from the keyboard and putting this into this temporary object. But if I make this operator return a constant money object, then this will work because output is a const function, but this will not work because input is not a const function. Remember, we define them that way. Input is a non-const function, output is a const function. You cannot call input on this result of this operator plus, but calling operator is okay. Okay? Was this your question? Yeah, this is the answer. You ask some other question that I said I'm going to answer.
Why we use const in front of line 19, 20, for example?
Yeah, you mean this
If
const,
we
right?
don't use it, then this shouldn't wrong, right? We can input into
This const is let's make a repetition maybe. Review. This const says I promise I am not going to modify the other. This const says that I promise I am not going to modify myself. And the const says that whatever I am returning, nobody is going to modify it. Okay? Those are all the meanings. Three consts, they have very, very different meanings, right? Very, very different meanings. Again, the same thing. These are not complicated stuff. They are all simple, but it becomes difficult to remember all of them. So what is the solution? You practice it, okay? You keep writing it, okay?
But I understand first two, but the last one is why we const returned value.
That's what I said here, right? Here, right? Oh, no, here, okay? I don't want this to work.
Why?
What? Why? Why should it work? Because M1 plus M2 is a temporary object, right? If it is temporary, if it's going to die, what good comes out of it inputting numbers to a temporary object? Okay? We never said anything like, okay? Cn A plus B. Does that make any sense? C out A plus B is okay. We keep doing this all the time. But this is bad, right? A plus B is a value. How am I going to change a value? We don't like this. We don't write it. And the compiler objects to it, right? But this one is okay. The same thing here, okay? This one is okay. Write the temporary output to the screen. But this will not okay. If I don't return a const object out of this operator plus, then that's what's going to happen. This will be a legal thing and very useless thing. So let's get some help from the compiler, use this const properly, and it will work. Okay. So are there any questions? Good. Okay, let's stop here. I'll see you tomorrow.